Hello. Welcome to Chemistry with Commodore or Chem with Com. Today we're going to be talking about atomic structure and significant figures. This is part one of a three-part video lecture. And specifically, this video is going to be talking about atomic structure. So let's get started. All right. What are atoms and what is matter? Well, atoms are the smallest unit of matter. What does that even mean? Right. So let's take a penny. A penny is made up of copper. Copper is an element that's found throughout the universe, and it is on the periodic table, and it consists of, if you break it down to the smallest piece, it's an atom. Well, let's envision that. So let's take a penny, single penny. We're going to break that in half. So I'm going to kind of draw this here. We're going to take a penny. We're going to break it in half. It's just going to be I'm not the best artist, but you'll kind of see where I'm going with this. And then let's break that. Let's take one of those pieces and break that in half. Right? And let's get smaller and smaller and smaller and smaller until we're just, let's say, at 2 atoms. We're going to pretend these little spheres are atoms or pictures of atoms. So let's say we're at 2 atoms here. Okay. Let's say we break that apart into 2 atoms, right? It was bonded together, but now they're separate. Now, what happens if you break this atom apart? Is it still going to be copper? Right? Different elements on the periodic table. Let's name a couple. Something that we're familiar with, right? Let's say oxygen, copper, and gold, right? They're all elements on the periodic table. They all consist of atoms. But let's say this is a Cu will stand for copper. Let's say this copper atom now. If we break that apart, will that still be this color? Would it still have the same chemical properties that copper does? Copper is found in wires that we plug into the wall, or phone chargers, laptops, TVs, right? You plug that into the wall, it conducts electricity. If you broke those atoms of copper up in half, would they conduct electricity? Don't know. Probably not. They no longer, once you get smaller than an atom, you no longer retain the chemical properties of that specific material. So if we break apart a single copper atom and it's smaller than an atom, it may no longer have that same chemical properties. Right? Same with gold, same with oxygen, all these different elements and atoms, right? The atom is the smallest unit that still retains its chemical properties, right? And if you can envision this, right, we are made up of atoms. Copper are atoms, right? Why are we so different, right? Well, it's all in the arrangement. It's all in the what's called the atomic structure, right? So it's very important. So these are some chemical symbols you'll find on the periodic table, right? Aluminum, you got bromine, calcium, carbon, chlorine, chromium, cobalt, and you have some kind of odd ones, right? Like copper. Copper is not Co, it's Cu because the Latin name was cuprum that we never changed. Fluorine is F. Gold is aurum, Au. So you're going to encounter some elements. They may not be similar to the symbols, right? They'll be a little different. Same with this. Potassium is calcium. So we're going to use a periodic table a lot. Hg over here is mercury. So we'll use a periodic table. We're going to have to know the symbols and the elements eventually. All right. All right, this is the periodic table. This is the complete periodic table. I'm going to mention things over and over again because I want it to stick. We're not going to be using most of the some of the periodic table, but the units of the periodic table, these numbers here, usually the ones with the decimals, those have various units. They could be in grams per mole or atomic mass units. And we'll repeat this and get this kind of, well, I'm going to throw it at you a bunch of times so that it sticks, right? This is what we're mainly going to use for the periodic table, right? The other stuff gets used every now and then. We don't use it a lot in these levels of chemistry. But again, I want to reiterate these numbers here. They're called atomic mass, and they could be grams per mole or atomic mass units. So hydrogen is 1.008 grams per mole, or hydrogen is 1.008 atomic mass units, right? That's the atomic mass right here. Over here is the atomic number, right? Atomic number is just the amount of protons. So we'll say number of protons. We'll get to what protons are in a little bit or next slide. And this is the name, this is the symbol. Over here, these kind of pink colored elements here, these are what are called semi-metals. They kind of act like metals sometimes, sometimes they don't. All right, everything to the left of those are called metals. And you know what metals are, right? We mentioned them earlier, copper, silver, gold, aluminum. You can just go down the list. Sodium, lithium, potassium, titanium, iron, zinc, all those things are metals. On the right side here are the non-metals. So some of them are carbon, nitrogen, oxygen, fluorine, neon, phosphorus, things like that. So we're going to have to use these. And over here, hydrogen, this is also a non-metal. It's a different color. We're going to talk about the arrangement of the periodic table soon. But for now, we're just going to call that a non-metal. All right? So we'll revisit this and we'll really learn this stuff. But let's go back and figure out what all the stuff is. This is what we're really going to use. We teach a lot of chemistry just on these elements here. We do venture, this is the first and second row of the periodic tables. This is that big gap. Again, I say this over and over again, but these are in units of grams per mole. And you're not even sure probably what a mole is. Grams you've heard of, right? It's a unit of mass or weight here on Earth. And atomic mass units, maybe you're not familiar with that either, right? We'll get into what both those mean. And yeah, let's move on. All right, so atomic structure. This is what I want you to envision when we start talking about atoms, right? So envision that we are in a big football stadium, and that is going to be the boundary. The outside of the football stadium is going to be the boundary of our atom. That's what these little submicroscopic structures are, right? These little pieces of matter. A single unit of matter, again, is an atom. We're going to pretend that is a giant football stadium. In the football stadium, so I'm just going to draw, this isn't going to be to scale, but just kind of something to reference. In that stadium, there's going to be a tiny blueberry. And that blueberry is going to be what's called the nucleus. It's whatever is at the center. So we'll say nucleus. Right? And then in the nucleus, there are going to be some smaller particles called a proton. That's what we referenced earlier, right? The number on the periodic table here was the atomic number, but that's also the amount of protons. So each specific element has its own number of protons, and that gives that element its chemical properties. Right? So every element will have a different number of protons. So if we go back up here, right, the reason why silver is silver because it has 47 protons. The reason why gold is because it has 79 protons, right? The reason why copper is because it has 29 protons, right? And oxygen is 8 protons, right? Every single element has its own specific number of protons. All right, and each of those protons are have a positive charge to them. All right. Also in the nucleus, you can find what are called neutrons, and they don't have a charge. All right. So that's the nucleus, right? Size of a blueberry. They have positively charged protons and neutral neutrons. And flying everywhere and everywhere around this stadium is going to be this little tiny microscopic, not microscopic, but it's about 2,000 times smaller than a blueberry. So we'll say blueberry is a nucleus. And we'll say the tip of a mechanical pencil lead is a what's called an electron, right? It's a tiny, again, it's not exactly the scale, but we're trying to give it some sort of scale, right? So electron, they are negatively charged. We're just going to put a little dot there. So I'm just going to put an arrow so we can see it, but it's really, really small, right? So again, atom is the stadium. The nucleus is a blueberry in the center. It contains positively charged protons, neutrons with no charge. Most of the time they have neutrons, not all the time, but most of the time. And then flying everywhere and anywhere in that stadium could be this little tiny speck of a mechanical pencil lead, and it's going to be a negatively charged electron, right? So when you're envisioning the stuff we're doing in class and experiments, we're going to be go back to this picture you're placing in your head, and we'll use that. All right. So here's some more details about these subatomic particles. Sub means below, right? So something smaller than an atom. So we're not going to be using this much in this class. We're also not going to be using this in this class. Let me just show you something first, though. So these particles that are sitting in the nucleus, right? There's an electron. Yeah, let's just skip this. Atomic mass units, that's in grams. These are what are called atomic mass units. All right. So if you look between the difference between an electron and proton, this is about, not exactly, but 2,000 times smaller. All right. Protons and neutrons are about the same size. Even though these are much different in size, electron carries a -1 charge or a 1 minus charge, and a proton carries a 1 plus charge. A neutron doesn't have a charge. All right, and again, the units on the periodic table are grams per mole and atomic mass units. All right, so let's take a look. We said atomic number, that's going to be the number of protons. So here, let's go back up to our, here, this is our number of protons and, or not plus, sorry, let's erase that, not a plus, and, or the atomic number. It's the same things. We're going to go back and forth calling it the same thing or either one of those, right? But it's the same thing. It's the atomic number, but that's also the number of protons. All right. So that's the number of protons. And also, most atoms have neutrons. So if we're talking about a mass number, so let's figure out let's do something for helium. So let's take this here. Helium has an atomic number of 2. So I'm going to say helium or helium has an atomic number of 2. So let's just pretend this specific atom of helium had 2 neutrons as well, right? All helium have 2 protons. But we could say this specific one has two neutrons. So number two, so it's going to be two protons plus two neutrons. This is going to be four, and that's going to be the mass number, right? So a mass number is going to be the number of protons plus the number of neutrons. And you can go back and forth, right? If you have it's going to always be this formula. So let's put that back into this formula and figure out how many neutrons it could be. So let's say we had helium with a mass number of 5, right? We always know all helium have a number of protons, and that's going to be 2. And it's going to be plus a mass number of, and we don't know what it is, or neutrons, we don't know what it is, right? So we'll say neutrons. So we're going to say, we're going to subtract 2 from both sides. So that becomes 3 equals the amount of neutrons, right? Because 2 cancels out and we just have a mass number of 5. I'll erase that. I'll just maybe put it in parentheses and say helium. Okay. This is going to be our A, which is our A here, equals number of protons, which is the Z, plus neutrons, right? So if we have the total mass number, if we subtract the protons, we can find the neutrons. If we have the mass number and subtract the neutrons, that'll tell us the protons, right? So go ahead and try that a little bit, and let's review some of this here. All right, so here we learned what is the charge of an electron. We learned what the charge of a proton is, what the charge of a neutron is. We've learned what has more mass, an electron or proton. We learned the kind of the relative sizes of a proton and neutron. We found out where the electrons, protons, and neutrons are located. We knew what particle defines the element or gives the element its specific properties. We looked at an atomic number, mass number, and these different units of mass on the periodic table. Now, if you didn't get the answers to these questions, rewind the video and review the questions. And the secret word for this specific video is daisy. All right. Well, thank you very much. And let's call it quits, and we'll start and we'll get a new video next time. Thank you.